Good day everybody, and we are happy that you've taken time to look into this tutorial about first hands-on experience with the XACT. And today I will give you some quick overview of the high resolution online quantification of trace metals in particulate matter using this nice instrument. People will actually ask themselves, why do you need to quantify trace metals? And that's always a significant and very important question, because if we don't know that these trace metals are very important for heterogeneous reactions in particulate matter and important for in-cloud processes, we will not actually understand why people put in so much effort. They are also very important for human and plant physiology. But when the humans have a lot of them, it can become toxic. And toxic, as you know, mercury and lead, when you have a lot of them, you have some brain damage. Mechanisms of how these trace metals can actually affect these health effects are known. Some people, and there are studies that have shown that reactive oxygenated species form through interactions with these trace metals, and these are mechanisms that lead to oxidative stress in some organs of the body that leads to health effects. But one other very important thing about these trace elements is that they can help us to tell us where those metals come from. And that is something very important for field measurements, because we like to know where are the sources and which guys emit them. They are usually in nanograms per cubic meter concentrations in the atmosphere. That's quite small. Hair size is just tens of micrometers, and these are 1,000 times smaller than your hair size. So to quantify them is also a problem. So usually people used to collect this particulate matter on filters over 24 hours or even a longer time period. You need to go to the lab to digest, wash out the filters, and do a lot of acid processing with the filters to be able to quantify these small metals. But it's a challenge, because when you do 24 hours measurement, it's difficult for you to have hotspots or emissions that are coming from the source to quantify them quickly. So due to all these difficulties, people have been thinking of how to improve the quantification of trace metals, and online techniques are becoming more attractive for researchers, because with this you can actually pinpoint some emitters, some pollutants, and know exactly what they pollute. There are different types of online techniques out there. About 3 major suppliers of HORIBA, Chinese company. They also produce online techniques. But today we'll talk about the XACT ambient continuous multimetal monitor, XACT 625i from Cooper Environment. This is quite a novel technique, and it's used in most European institutions nowadays. And it has an advanced automated high-resolution multi-element analysis system in various matrices, so you can quantify different type of matrices with it, not only particulate matter. The most important thing is that it's based on a reel-to-reel filter tape sampling system, and you have particulate matter coming in, they are sampled on a tape, and the tape moves from the sampling system to a detection system, where we use X-ray fluorescence technique to quantify these elements. Non-destructive, because you can still quantify the filters after you have already analyzed them. One of the most important things is that the XACT has a standard protocol for 44 elements that you can quantify. But when you're in the field, you're always thinking about the time resolution. So you have to get information within every time span. The XACT can actually measure from 15 minutes to 4 hours time resolution, but you have a trade-off between the resolution and the sensitivity. If you go for quicker time frame like 15 minutes, then the sensitivity is not as good as if you go for 4 hours. Most environmental protection agencies, they go between 1 hour and 2 hours. And most often in our campaigns and in most of the studies we do, we also go for 2 hours. Now I will switch to the instrument and tell you how it looks like inside and how certain aspects can be run. So now we'll have a quick look into the inside of the instrument. The first thing you realize is the reel-to-reel setup. So you have a filter tape here which you can mount by taking off this knob. At the beginning you have the new filter here and an empty holder here, a band holder. This band hole enables you to pull out the tape through tape support under the sampling inlet tube below the X-ray unit, detector unit, and with this filter guide you stick the other part of the tape on this holder. So when that's done, you have now the inlet of the particles will come through this tube and they'll impact on this part of the tape. The air will be pulled out through a pump here out. After sampling, the field being moved electronically depending on the sampling time, 15 minutes after 15 minutes or 4 hours after 4 hours. It's been moved into the dictation unit. This dictation unit comprises of the X-ray tube. Here's where the X-ray is coming from, and the dictator setup is here below. So the X-ray will be impacted here, the fluorescence will be generated, and the dictator will quantify the fluorescence signals of the particles. Here is a sensor. Usually when you're installing tape, make sure that the tape goes below the wheel and not above the wheel. The reason is if you put it above the wheel, you can touch this sensor, which is here, that controls the movement of the tape. And as such, you have difficulties in functionality. And when the tape is below, the particles will also go into the excitation chamber, which is almost in the middle of this block. And there you have the particles being impacted. You can see here, and this is an example of the spots that is being quantified. And these spots are now being quantified by the X-ray tube. So you have a dynamic rod here. The dynamic rod has also some elements, chromium, palladium, cadmium, for the quality assurance of the instrument. For instance, the copper rod takes some measurements each night to align the energy. The palladium rod is always placed in excitation chamber in each of the measurements, internal standard. Check if the excitation and the dictation, they are working very well. They are all within this dynamic rod, which moves in and out of the setup. One other important thing is that you have some sensors to protect you to have the X-ray. So whenever the instrument is open, the door is open, these sensors are activated and the X-ray tube goes off. So that's a very good security measure that Cooper has done to safeguard the setup. Now we can look behind the instrument and try to start the measure. So now we are at the rear side of the instruments, and here you have different connectors. Here's the connection to the pump. Here's the power supply to the pump and the weather stations. You have the internet connection here. You have the wind sensor connector and the heating unit. This heating unit is good under high relative humidity conditions. You have the egg here, which is good to always add the instruments, and the power setup. There is a procedure how to switch on the instrument. You need to make sure that you first switch on the main power, and then when you switch on the mains, the instrument starts. Now we have switched on the instrument, you switch on the software, and then you have the control unit of the software. To have a better look into it, we'll switch on to TeamViewer, where I can give you a better overview. Now we are in the exact control unit, and when you open the exact control unit, this is a window that opens. You have different menus. Here's the status. This is the start side. You will see if the instrument is on or is off, and you see those other parameters. And you have other aspects like the data, the system, the settings, the flow. These are all different menus that you can look into in detail, or the maintenance unit. In this tutorial, I would like to focus on the ADAPT software, which is a data processing software, which we use to have quick looks into the data we have sampled. Here you have the main. This panel goes through a web browser, so you need to have a web browser in the system. And here you can see the concentrations of the various elements that have been sampled. You can put a time frame here where you want to look into those data, and the ADAPT will give you the analysis just with the time frame you're interested in. You have 4 different elements I showed you. You have the time series, for instance, from the last samplings we did. This is from 29th of May to 30th of May. You can see the values here. You see which elements have these values and their time evolution. So you can now go into a detailed analysis for different time frames look at the average concentrations here. I've put in the time from January to April this year, 2024. We can look at the various elemental concentrations here. For this time frame, you have the average concentrations, the relative contributions of the elements. Silicon was quite abundant, sulfur and calcium. You can go into the temporal trends to see how each of these elements, they varied over time. Here, I can look at sulfur. You can see how sulfur concentrations change with time. You had high concentrations during this period and then lower concentrations during this period. You can do the same for calcium. You can do the same for silicon. You can also go into daily distributions of the elements. Here you can see the daily distribution of sulfur. All of these measurements were done for 2-hour time frame. So there will be some averaging to get them in the daily distributions. You can see the quarter ranges, the mean, the median. Another interesting aspect is that you can look at time of day trends. The time of day trends is quite interesting because you can look if there have been significant changes during the day. If you have high concentrations at a specific time compared to a different time of the day, you can look at different elements. You see potassium has lower concentrations during the day than in the evening due to combustion. You can look at the week trends. This is quite nice because it can tell you which time of the week people emit which elements. So you can say Monday to Sunday, from midnight to midnight, which time of the day is sulfur emitted most. Potassium is a nice example because it's a good proxy for combustion. From Monday to Sunday, you see that there's a lot of emission of potassium in the region we sample over the weekends. This could be related to heating during this time, especially with wood. You can look at correlation analysis between the elements. And in this case, you can look, for instance, for aluminum. How does it correlate with the other elements? You see very nice correlations. The good advantage with this software is that it gives you very good quick looks. So it tells you for this time period, there was a correlation or not. But to make better plots, you need to export the data to a different software. You can now combine the concentrations with the meteorological data like the wind speed to now have some quick looks on where the concentrations are coming from. For instance, you can see titanium. This was a bit local, was not a lot transported. You can look at sulfur. Sulfur was transported from northeast direction. But if you look at something like potassium, you see that most of them was also local emission, which confirms the presence of emissions towards the presence of local sources. Actually, you can also have a directional concentrational plot like a pollution rose, which tells you how much of titanium or calcium comes from which direction. So with this, you have a very first quick look to understand what's happening in the field when you're sampling. And that's a quick overview of the ExAct and the ADAPT software. And we can now look at some various aspects. Finally, we'd like to give you some advantages and limitations of the ExAct. The main advantage is a real-time analytical technique. In real time, you get results immediately. You can do something with it and you can see so many things. It has low maintenance and operational cost, minimal sampling handling and preparation. You don't need to digest samples. Carry it to hotspot regions, so it's portable, it's flexible to deploy in the field. It has embedded analytical tools like the ADAPT software, very nice for quick looks. And it has high throughput, so for long-term monitoring, it's perfect. You don't need to go there all the times, and you can get significant information about source apportionment studies. And one of the disadvantages that it has is that it's a bit expensive to have so many of them. So to have 5 of them or 6, you need to have roughly €1,000,000 to deploy them to all your sites. Although it's quite important and very useful, you need to have some money to acquire it. However, there are also some difficulties in terms of environmental conditions. You would like to work under a temperature range so that the electronic functions well. So you cannot deploy it in winter conditions at minus 20 degrees without providing heating for it, which is not the case for offline sampling. For particulate matter, you have the inlet, as I showed you, that goes directly into the sample. You already have the inlet there, so it's easy to quantify particulate matter. But if you have to do the soluble elements from it, the procedure becomes a bit challenging, but it's possible. And for light elements, the sensitivity is not good, but from aluminum, you have good sensitivity to make. I would like to say, nevertheless, that ExAct is a robust tool to quantify trace elements at high resolutions with very good sensitivities, and high quality assurance measures have been taken, as I explained. Despite the high cost, it has low operational costs compared to other techniques, and it's good for target source apportionment studies, especially if you go close to the source of emissions. I want to thank you for your interest in the tutorial, and especially to thank the support of the European Commission under the Horizon 2020 framework for the Research Infrastructures Framework Program ADNO Access for supporting this activity financially and making it possible for us to do this tutorial. Thank you.